I have a look, number one, and I see my biggest issue, the first thing I need to sort out is all this fraction rubbish, okay? You've got divided by 5, divided by 3, divided by 10, and it's all a bit of a mess. So before I do any like shifting things from different sides, collecting like terms, etc., I want to get rid of all of these three. It'd be really nice if I could multiply through by a single number that'll get rid of all of them. Any suggestions? I'd like to multiply through. I don't have to. I can do this in multiple steps. But I'd like to multiply through by a single number that'll get rid of dividing by 5, dividing by 3, and dividing by 10. Okay, now multiplying everything by 30 is going to be, it's not the only way, but it will certainly be the quickest way. I would say probably the most common other thing is you maybe multiply by 150. 150 is 5 times 3 times 10. And that'll work just fine. You'll just get enormous numbers that get to cancel out later. So let's try this out. If you didn't multiply through by 30, here's me giving it a go. 3x on 5, that 30 and the 5 on the bottom, they'll cancel, leaving what? What less gets left behind? 6, right? So there's going to be 6 lots of that 3x. This is number 1. So 6 lots of 3x is 18x. You okay with that? When I do 30 times a third, the 30 and the 3 will cancel, again leaving behind a number which is 10. And then on the right hand side, the 30 and the 10 cancel and you just get this guy. Yep. How's it look? I'm pretty happy with that, okay? So now I'm going to subtract 3x from both sides. That'll give me this. I want to get the x by itself, so while I'm at it, I might as well subtract 10 from both sides. Yeah?
Where did we get the 10 from?
I got it from here. Yeah, 30 times a third, yeah. So, looks okay to me. And then the last thing I need to do before I write down Nick's line is to divide through. But it's not quite there, is it? Well, it's not quite that. What's the difference? What's gone wrong? Maybe I should ask, which is wrong?
Oh, it's not 1.18. Sorry, it's not 1.18.
So the next thing I need to do, I need to cancel, right? So I'm going to divide this by 5 and divide this by 5, and that gives me, rather than -3 on 2, I'm thinking it's -2 on 3. It's pretty close, isn't it? Like, it looks like you've done all the hard legwork, all the tricky stuff, but at the end here, it's an easy mistake to make, isn't it? Like, you're dividing through by something. At which, you mean at this point here? I just want to make it simpler, that's all I want to do. I see there's a common factor of 5 for the numerator and the denominator, so I might as well get rid of it. Okay. What do people think? Satisfied?
Yes.
Okay, cool. So let's pop this off. Let's have a look at number 2. Now, we'll do them one at a time. Area's already there. We'll get sort of the perimeter in a second. Now, what you've got here, maybe it will help, is I did suggest to you drawing a diagram would be really helpful. For composite shapes like this, to understand what's going on, if you don't draw it yourself, you're just at a much higher risk of like, what is this shape and what are the bits and pieces I need to take apart? So if I add on this like bottom half, okay, you can see there's like a big circle and then there's a little circle. And what I've got is the difference, okay? By the way, this shape, it has a special name if you're interested in special names. It's called an annulus, okay? So you guys know like a tree trunk, like a big tree trunk, if you cut it open and then it's like, it's got rings, right? They're called annular rings. Anyway, yeah, that's right. It's about years of, anyway, I won't go into it. So if I think about this problem, this big problem, I've got a big circle and I need to take away a little circle. So I'm going to say area equals, and I can do 2 circles, right? I can do 2 circles. I need a pi r squared. I'm going to tell you why. Maybe you can tell me why. I have a capital R there in a second. I want to take away another pi r squared. So you see why? I've got a big radius and a little radius. So this is just a nice, easy way to say there's 2 of them. But that's this extra problem. I actually only want half of that. Do you agree with that? Do you see how I unpacked that, right? Now this line here, is it going to get you any marks? Yeah. Probably not, but if I don't have a line like this, it'll be pretty hard to have any confidence that I'm going through this correctly and getting the right thing out, okay? So now that I've set it up, I'm just going to evaluate. So I've got this half out the front. I suppose I could take a pi out too. Do you see I've got a couple of pi's there? I don't have to write them twice. The big radius is, have a look. The big radius is 5, so this will be 5 squared, and the little radius is 3. Cool. So let's just crunch it through a little bit. This is 25 take away 9. 25 take away 9 is 16. 16. So 16 pi over 2 is, I think, 8 pi. And then I was asking for two significant figures. So if you can go ahead and punch in 8 times pi for me, I'm guessing that'll be
25.
25. Yeah, so if I just go ahead and actually do this will be 24 point something? Or is it actually over 25?
Yes, it's over 25.
Can someone tell me what the actual, because
Well, it's 25.1327.
yep, good. Dot, 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 dot. So now I'm going to round to my 2 significant meters. Meters squared. Happy? Okay, do you see how I went through it?
Yeah.
Okay, with the perimeter, much the same thing. Let me get rid of this guy. Okay. Do you want to find out what the number is, or are you content for me to just show you how, and then you can work it out yourself?
Is it 20?
Do you want the number? Okay. All right. So again, I want to think about there's 3 components here, or depending on the way you count it, 4. Okay. There's a big semicircle, or just the arc. There's a little one, and then there's these 2 intervals, these 2 straight lines. Okay, so these are the easy bits, 2 plus 2, and then I've got to work out this guy in here. This is half, what's the circumference again? If that's the area, what's the circumference? It's 2 pi r, right? So I would say half times, it's half because it's a semicircle, 2 times pi times 3. Yeah, I can, but I'm trying to, like, you see I can cancel these 2, right? But I want to show I know what I'm doing, right? So once these 2 do cancel, they become 3 pi. You happy with that? Do you see how I did it? I could repeat that process again on the outside. You already told me what the big radius was, so I believe you should get 5 pi for this guy out here, okay? Because it's going to be a half times 2 pi r again, but it'll be a different r. It'll be this one. Does that make sense? So let's have a look. Which are the lengths that I'm actually adding up for my perimeter? I've got 1, 2, 3, 4. Does someone tell me what 4 plus 8 pi is equal to the 2 significant figures? Someone got it?
29. Yes.
Yeah.
Two significant figures.
Yeah. Okay. I'll just leave it there because you guys can see the decimal place yourselves. Didn't someone say 20? I thought I heard someone say 25. Yeah? Cool. Well done. Fantastic. Okay, last one. We'll do this one really quickly. 3.5 is what we think it is. Let's see if we can confirm that, okay? 2 red marbles for each blue marble. So even though I never said it anywhere in there, this is a ratios question, okay? Because like for every one of these, I've got 2 of these, okay? So I'm going to write it like this. Red to blue is equal to, now is it 2 to 1 or is it 1 to 2?
2 to 1.
It's 2 to 1. So you match this with this with this, right? So red to blue, 2 to 1. Okay, so that's good. And then they start talking about thirds. And we don't know how many marbles there are in there, okay? So we're going to take advantage of the fact that you can convert that ratio to an equivalent one that you can divide into thirds. The smallest number I can think of would be 6 to 3.
I did it.
Okay? Now, I don't know if there are 6 or 3 or 60 or 30 or whatever, but I know that they'll be in that ratio. They're equivalent. Okay? And I did see some people doing that working. So what I'm going to do is take a third of the blue marbles, right? A third of these away, right? So that's like taking 1 and moving it over to this column. Does that make sense? 7 to 2. Okay, so this is like when we were doing that reinvestment thing, like so-and-so had bonds and then they had shares and then they moved money over. So I have moved a marble or a third of the marbles over. I'm 1 step away from answering the question. Have a look. What do I have to do to this thing now? Yeah, I want to know for each blue marble, that means for 1 blue marble. So I've got to say I want that to be 1, so I've got to divide through by 2. That gives me 3.5 to 1, which is a bit unusual, but it helps us answer the question. Okay? So good job, Maddie, for nailing that first go.
How did you get from 6.7?
This one to this? Oh, okay. I actually did something a bit naughty. I did something a bit naughty. So these are in fact not the same, are they? Right? What I've done is I've changed things based on if I take a third of the blue marbles away, a third of these guys away, and then replace them with red marbles. So I've taken 1 out of this group and I've placed it into this group.
Yeah.
Okay? And that's where's the word? Replace.
Yeah.
That's how I know what's happened. Yeah.
So it's 3.5 miles.
Yeah, correct. So the answer, the actual answer, is exactly what Maddie put down in the first place, which is 3.5 or 3.5. Either way. All right.
Yeah.